this first. Okay, share my screen now, sharing my screen now. So for this afternoon, we'll be talking about the fundamentals of differential equations. And of course, it has to start with a review of the mathematical tools that you will be primarily using in this course. So you will be using differential calculus and integral calculus. I did not anymore place here a review for algebra and trigonometry because actually they have been repeatedly taught to you, shared to you by your teachers since high school. So what I have here is just a review of your calculus subjects. Okay, so for now, we'll start with this two items. So it asks, number one asks for the second derivative of 3x cubed plus 2 over x. Number two asks for the derivative of the quantity 3 square root of x minus 5 raised to 8. So let's see if you still recall your differentiation techniques. And I'll be waiting for those who are ready with their pens and their papers there, and give me the answer for the derivatives of these two. That is the answer for number one, the second derivative, for number two, the first derivative. Number one is very easy. Even number two is very easy. These are just but differentiation. Anyone?
Excuse me, miss.
Yes.
For number one, the answer is D, miss.
Okay, the answer is D, correct. So number one is D. Thank you for that. What about number two? What about number two? If you don't have your mic on, you can use the chat box. You can place your answer in the chat box. I will read those answers. What about number two? It's just a simple case of chain rule. Chain rule applied to differentiation. What's number two? CHE, what about number two? It will not take you more than 30 seconds to finish the differentiation of this. What's number two? If you're having difficulty differentiating this one, I don't know what to expect in the real differential equations later on. Because this one is even mechanical compared to real differential equations. What's the answer for number two?
Excuse me, miss.
Yes.
Still letter D, miss.
So this is still Isaac. What about the others? What about my students last semester? This should be even fresher in your memory. Okay, Isaac is correct. The answer is letter D. Okay, I will not bother to place in there the solution because this is supposed to be review. So I'm not supposed to teach calculus here. I hope I'm not wrong. I'm supposed to teach here differential equations. Okay, so I will proceed with the next slide. Now, what do you have here on the next slide? I will just first clear the markings here. Let's, excuse me, class. Okay, you're seeing here two problems on differentiations as well. I'd like to have my students last semester to answer this. Find the derivative of, by the way, there should be an F here. So this should be an F of X equal to the square root of secant x squared. And for number 4, you are asked to find the derivative of the log of x cubed minus 2x to the base 4. Okay. Feel free to chat on the chat box what is the answer for these two. You may type the letter only corresponding to the correct answer. Let's see. For number 3, it's letter B. Is it letter B? Yvette says it's letter C. The answer is letter C. Okay, the answer is letter C. What you're going to do here is you're going to use again chain rule. So you will apply first power rule because your second function is raised to the power 1/2, then that would be power rule of differentiation. Then it will be followed by application of differentiation on the second x squared function, which will require for the derivative of the secant of x squared and the derivative of the argument of the secant, which is x squared. Okay, so it's letter C for number 3. Okay, what about number 4? Okay, so John, Gio, and Kent also answered letter C. What about number 4? What's the answer for number 4? Okay, number 4. So Jules says number 4 is B. The same thing with Nika. So that's correct. Very good. So your number 4 is letter B. Now, if you have forgotten already the chain rule in differentiation or the differentiation concerning log functions, trigonometric functions, please do review them because you need those in here. Same thing with your last semester's subject in integral calculus. So now we're done with the review on differential calculus. We'll have integral calculus. Okay, so you have two integrals here. The first one is the fourth root of x to the fifth. And the second one is 8 cosecant y multiplied to the quantity cotangent y minus cosecant y. What do you think is the answer? You may chat them on the chat box, or you may type the letter corresponding to the correct answer in the chat box. Okay, I have 2 here. So for number 6, what do you mean number 6? For number 1, it's letter okay. It's letter C, correct. Okay, it's letter C. Number 1 is letter C. And what about number 2? Number 2. So Ken, Gio, Ernest, Cholo, Nika, Bobby, C. Okay, what about number 2? What's the answer for number 2? You need first to simplify the expression written after the integral sign prior to applying an appropriate technique or formula. What do you think is the answer for number 2? Yvette says it's letter D. Very good, Iha. The same thing with Nika. Letter D. Okay. So the answer for number 2 is letter D. Now, okay. Gio also answered D. Same thing with Michael. Now, we go to, let me clear the things here. We go to the next slide. The last 2 of the integrals. Okay, number 3 gives you a fraction, a rational expression to be integrated. And number 4 gives you a second function in which the argument is an exponential function. Whenever you're given a rational expression or a fraction, you have to check the degree of the polynomial in the numerator, the same thing, excuse me, with that on the denominator. So if the degrees are the same or if the degree of the numerator is greater than that of the denominator, you will divide. If the degree of the numerator is less than the denominator, you are to check if ln will work. So ln, or if not, you have to factor the denominator and use the method of partial fractions. Or simplify first before you use the method of partial fractions. Okay, answers are already in the chat box. Okay, so Bobby, Sean. Okay, the answer is letter A for number 3. So number 3 is letter A. The derivative of this will need your numerator to be multiplied by 3 and you need to place 1/3 before your integral. So the answer is A. What about number 4? Number 4 is A. Bobby. Okay. Gamali-mali na si Bobby sang type. So your number 4 is letter A. This one can be written in the form second squared e raised to 4x. And we know that the second squared is the derivative of the tangent. So you need to make sure that this e raised to 4x is in here because it's its derivative. You lack 4, so you introduce 4 here. You place 1/4 outside. So Bobby is correct. The answer for number 4 is letter A. Should be tangent e raised to 4x divided by 4 plus C. So thank you everyone for answering or for participating. Okay? Really happy if my students are able to participate. Though right now, I'm already thinking what happened to your differential calculus. Why? Because you can even answer your integral calculus faster than your differential calculus. In my opinion, differential calculus is even a lot easier than integral calculus. Probably you have short-term memories. Okay? Short-term lang kamo, hindi kamo long-term. So ang dugay na, hindi nyo na madumduman. Okay, so now we proceed to our main topic for the afternoon, and that's the differential equations. So when you speak of the differential equation, it's the same with other equations, only that we have what we call the function and its derivatives present on it. If your equation does not contain any derivative, your equation is not a differential equation. It's just an ordinary equation. It's not a differential equation, or it might be falling on other categories or other types of equation, but the requirement is your equation should have the presence of a derivative or of derivatives for it to be called a differential equation. Now, we have two types of differential equations, the ordinary differential equation and the partial differential equation. So in your differential calculus, we mean ordinary differential equation if the derivative that you see are using the d, the ordinary derivative like dy dx, dv dt, or second derivative of s with respect to t, something like that. So this is ordinary. Your equation or your differential equation is referred to as an ordinary differential equation if the derivatives you're seeing are something like this. Now, whenever you see this symbol, like this, this is already a partial differential equation. Why? Because you have, this is referred to as the curly D. Most faculty call this the curly D. So it's easy to tell that your DE is a partial DE if you see the curly D. But the thing is, if you're going to base the differentiation of the two types on mathematically what is found there, this is how they should be differentiated. We speak of an ordinary differential equation having only one and only one independent variable. And your partial DE has more than one dependent variable. So now I'm mentioning about dependent variable and independent variable. So you could see here in this particular, I'll use this as the example. The variable that appears in the denominator, in this case, that is the x, this is the independent variable. The variable that appears in the numerator of your derivative is the dependent variable. In some books, it's also referred to as the function or the unknown function. Now, if this is the derivative that you have in your differential equation, your independent variable is t, your dependent variable is v. This is your unknown function. Here, your unknown function is s, your independent variable is t. So it should be noted that when we speak of an ordinary DE, we only have one type of independent variable. It's not an ordinary DE if your differential equation has more than one independent variable. In that case, it's now called the partial DE. In this particular example of a partial differential equation, you will notice that in here, you have y as the independent variable. On the second derivative, which is a second order derivative, you have already y and z. So the entire partial differential equation has two independent variables, and those are y and z. The dependent variable is x. So the dependent variable is x. So the two are actually distinguished based on the number of independent variables that it has. So ordinary only one, partial more than one. So that's it. But if in terms of the look, if we'll just simply base it on how they are written, on how they look, then it's so easy to tell which is partial and which is ordinary. So this is ordinary, this is partial derivatives. Okay, then, oh, sorry. Then we go to the next slide. Now, when an equation involves one or more derivatives with respect to a particular variable, the variable is called an independent variable. So the variable present in the denominator. A variable is called dependent if the derivative of that particular variable occurs. Those that are not variables, meaning the letters that you see in your derivative are your variables already, either independent or dependent. What about if you see other letters in your differential equation or other symbols? So we call those letters and symbols as parameters. They are not to be considered as variables because the variables are the only letters that you see in the derivative itself. So if a letter in the alphabet is not found in your derivative but appears in your differential equation, it's a constant. It could be a constant or it could be what we call as a parameter. Now, in terms of the order and the degree of the DE, so let's look at this. The order of the DE is the order of the highest order derivative appearing in the equation. You have to look for the highest order derivative in your equation. Whatever that order is, that is also the order of your DE. On the other hand, when we speak of the degree of the DE, it's dependent on the highest order derivative in your DE. You have to know or you have to check as to what exponent or power it is raised to. So if your highest order derivative is raised to an exponent of 3, then the degree of your DE is 3. If it's not raised to any other exponent, it is understood to be degree 1 because we don't write normally the exponent 1 in anything. So it's understood to be of power 1 or exponent 1. So first, determine the highest order derivative. That is the order of your DE. Then check its power or its exponent, that is already the degree of your differential equation.
Miss, question, Miss.
Yes,
Ang degree, Miss, dapat whole number gid na.
no, it could be 3 halves, 5 halves, 1/4, depende. So you may answer of degree 3 halves, of degree 1/4, but oftentimes what you see in books, they are whole numbers. But they can be fractions. There are examples, you can look on the internet. There are examples in which the degree is not a whole number. Okay? If you're going to go back to textbook, it does not specify that the degree has to be a whole number. Need not be a whole number. As long as it is the power to which the highest order derivative is raised to. Now, we go to linearity of the differential equation. Now, if your derivatives in the differential equation have powers all equal to 1, your differential equation is said to be linear. Although, if you're going to look back or if you're going to refer it to Shom's outline in differential equation, there are still other tests to check whether your differential equation is linear. For now, we'll just leave it to this, that whenever the exponents of the derivatives in your differential equation are all 1, then the DE is said to be linear. Otherwise, if it's not 1, let's say it's 0.5 or 2 or 3 or -1, then your DE is said to be non-linear. So it's only linear when the degree is equal to 1. Now, it doesn't follow though, however, class, let me just emphasize this. It doesn't follow that if the degree of your DE is 1, it's already linear. Like for example, I like to write this one. Doesn't follow that all first degree DE is linear. Okay. The order of this DE is second order. The degree is 1 or first degree. But you see this derivative, it is raised to an exponent which is 2. So you may wonder why this is nonlinear based on this particular idea in the parentheses. Not all first degree differential equation are linear because this is not first degree. This is first degree, but you see this derivative as an exponent raised to 2. So the entire differential equation is said to be nonlinear. Although that if this is first degree and we don't have this 2 in here, it's automatic that your DE is linear. So what I mean with degree 1 is like this. This one is first degree and all derivatives have exponents equal to 1. Actually, in Shom's outline, if you're going to base it in Shom's outline in differential equations, even the exponent to which your unknown function is raised to should be equal to 1 for your differential equation to be linear. If this is 2, this is non-linear, even if it's not 2. If this is 2, you seem to say that, okay, miss, this is of exponent 1, this is of exponent 1, so it's linear. No, because your unknown function here is raised to 2. So this makes this differential equation non-linear. This particular definition of a linear differential equation based on the derivatives being raised to 1 is limited only to the concept of elementary ordinary differential equations. But if you're going to look into other reference, which is a little bit of higher degree than the one that we're using, it even gives you around 5 to 6 different tests of the way the functions that are written in your differential equation should look like. That way you can readily say that your DE is linear. For now, we will just limit our discussion here because this is ordinary differential equation, ordinary simple differential equation. So this is how we say that it's linear. Okay, the
Miss
derivatives.
question tayo, miss.
Yes.
What if si dy dx ara siya susulod sang square root? I-manipulate ko miss ang DE nga i-multiply ko, i-raise ko siya sa 2 para mag-1 ang degree.
Well,
Or
it's
ang
the
degree.
only derivative that you see in the equation. Like
O akong let's say miss amo lang gina siya dy dx lang gid. Ara siya sulod
dydx.
sang
Anong imo iban pa? Kahit hindi man ni equation kung amo ni.
dy dx is equals to x squared yun, ma'am.
Okay. This one.
Oo.
Square root siya.
Oh, square root siya.
So you can raise
I-raise ko
everything
siya sa
to 2.
2
So this would
para
be
ma-1 siya.
y prime x to the 4th.
So ang degree yan na miss ma-1, hindi siya yung mag-1 half.
Oo.
Okay. So
The
dapat
degree.
i-manipulate naman miss ang DE para mag-whole number.
Not necessarily nga para
Necessary.
mag-whole number ang i-exponent. What if you have something like this? So, you cannot do manipulation anymore because if you want to really manipulate, you write 1 plus the square root of dy dx. Then you will have 2x plus y double prime, right? Then let's say, for example, you want to isolate this derivative here. You will have already, I'll place it here, square root of dy dx is equal to y double prime plus 2x minus 1. Is that what you mean? So if you're going to raise this one to 2, that way you can eliminate the degree of the DE here. The entire thing here is already, this is already a 3-term polynomial. You're going to expand it, meaning you're going to square it. That way you'll get to isolate this one. So automatically, if you see such an equation as this, there's no need for you to simplify. Why? Anyway, this is your highest order derivative. And it's being raised to 1. So this is the basis of the order of the differential equation. You simply have to check what is the highest order derivative. If it stands alone, there's no need for you to simplify. Stand alone like this one, it stands alone. So this is the order of this derivative is already the order of the D itself. We don't care about the other terms here. And in terms of the degree, we also base it on this particular term. Unless otherwise, maybe you have a derivative here in square root and have another expression here, the same derivative in square root, then maybe you can do the process of simplifying first. But as I said, if the highest order derivative is standing isolated, there's no need for you to simplify. Kiti ang basihan sa order, kag degree siya man lang mo, why simplify? Kiti siya man lang imo basihan. Okay?
Thank you.
Okay, okay. You have any questions? None. Okay, we're clear on the drawings here. We go to the next. Here you have the simple examples of the order and the degree of the DE. So the first one is first order, first degree. This is second order, first degree. This is third order, first degree. We can conclude that the first three examples are all linear, while all the derivatives are raised to exponent of 1. And we have only, in these two, we only have one derivative, and here we have two, but this one is also raised to an exponent of 1. So we can say that these three examples are all linear. What about the last three here? So this is second order, rather first order, second degree. Kaisa lang man siya. For this one, we have two derivatives, but this one is of higher order. So this is second order or order 2, degree 7 or 7th degree. So automatic, this is something like we don't look at it anymore. It's already out of the picture. We simply base our answer to the first term. Our last term is also standing alone in terms of the derivative on it. Siya lang isa. So order is 3, degree is 2. So this is how we determine the order and the degree of a differential equation. Okay, now we go to solutions. Solutions of a differential equation. So a solution of a DE is the unknown function or functions that satisfies the given differential equation. If I may say, class, the solution of a differential equation is an equation in itself. But we are certain that it is, in a way, in terms of form, the solution of your differential equation because it does not contain any derivative already. Or shall I say, the solution of any differential equation should not contain any derivatives. If it still contains a derivative or derivatives, then it is not yet the solution of your differential equation. What makes differential equations as well very unique is the fact that it is the only equation which may have all three different types of solutions. So it can have what we call as the particular solution, it can have what we call as the general solution, or the complete solution. Now, these two in the bottom, the general solution and the complete solution, has the presence of the arbitrary constant. What do we mean with the arbitrary constant? The C. C1, you see it in book C1, C2. So if whenever you see a C in the solution, then your differential equation is either general or complete. A particular solution, on the other hand, has only specific constants on it. So it does not contain any C. So a particular solution should not contain any C. But in terms of how they are defined in the context of solutions of differential equations, this is how they are defined. So any one solution can be a particular solution. The general solution is a set of solutions, and your complete solution is the sum of the particular and the general solution. Now, I said that the particular solution does not contain any constant, no C's. No C's. The general solution has at least one C. The complete solution has C, a number of constants, or number of C's equal to the order of the DE. What do I mean by this? If I am looking for the complete solution of a third order DE, the complete solution should contain 3 arbitrary constants. So normally they are represented as C1, C2, C3. Arbitrary in the sense that their values are not really specified. So it's a complete solution if the number of C's you see in the solution is equal to the degree of the given DE. Now, it is a general solution whenever you see at least one arbitrary constant. So having said these two statements, it follows, class, that all complete solutions are general solutions. Why? Because anyway, ang requirement naman sa general solution, at least one arbitrary constant. So if all arbitrary constants are there, it is also a general solution. So the complete solution of a DE at all times is also a general solution. Excuse me. Whereas a general solution may not be at all times equivalent to the complete solution. Your general solution will only be the complete solution at all times in cases of first order differential equation. Iti kung first order, siya ang order niya 1, so meaning arbitrary constant, kaya isa lang. So kung anong complete solution mo, amo naman na iya general solution. Whereas when you speak of particular solutions, wala gid kada iya sang C nga may makita. You shouldn't see any C. All numbers or all constants have been solved or determined using what we call specific initial conditions. For you to understand what I mean with initial conditions, let me go to the example on the next slide. Let's have this example. Prove that y equal to -2 cosine 4x plus c is a solution to the differential equation dy dx equal to 8 sine 4x. Then it continues with the question, what is the solution for the initial value problem where y is equal to 6 and x is equal to 0? What is this? So let me just clearly say this. Although the procedure that is written here is already a process of what we call separation of variables, if I am a student in your shoes and I don't know yet how to process using separation of variables and integral calculus, I will simply look back on what I've learned in the past, what mathematical tool that I have learned in the past. That way, I can prove or I can validate that this equation is a solution of this particular differential equation. How will I be able to do that? Very simple. Very simple. I will simply differentiate this. If the derivative of this expression is this, then I can say that this is a solution. Specifically, what type of solution? A general solution because it has one arbitrary constant. At the same time, this can also be the complete solution because the order of my differential equation is 1. Now, so let's see whether this is really a solution of this differential equation. This one, it's okay if I have already taught or discussed separation of variables, but since I was not yet able to do that, then we will leave it to that particular topic later on. So I will just simply use the tool that you have learned in the past. So I will differentiate the solution that is provided. So ano na siya bala? Y prime is equal to -2 negative sine of 4x times 4. As for the c, the arbitrary constant, its derivative is 0. If I will simplify this, this is 8 because this one is also negative 8 sine of 4x. So look, they look the same. Then this one is a solution of this DE. Okay? Let me erase. Now, Now, what will I do then? Next. So it says here, what should be the solution? If the value of x is 0 and y is 6, what will I do? This particular general or complete solution, I will substitute x equal to 0 and y equal to 6 and see what would be the value of the c. So you could see it here in number 2. So if we substitute, we'll have a 6 here. We'll have negative 2 cosine of 4 times 0 plus c. So this negative 2 is to be added to 6. It will give you a c which is equal to 8. It follows then now that with the use of the initial condition, we call this the initial condition, we are able to determine the particular solution. We're able to determine the particular solution of the differential equation using the general, also the complete solution of the DE. So when you validate, let's say when you're asked to prove whether a particular equation is really the solution of your DE, simply do differentiation and go back to the DE that was provided and substitute. If the left side and the right side of the equation are equal, then you're good. Then the provided solution is the solution of your DE. It's the same thing with this particular sample problem. Oh, what happened? Okay. So determine whether y of x equal to 2e raised to negative x plus xe raised to negative x is a solution of this second order differential equation. Since you see until the second derivative, there's a need for you to differentiate this twice. So this is your first derivative. Then differentiate this again. This will be your second derivative. What will you do with this? You go back to your DE and substitute. So we substitute the second derivative plus 2 times the first derivative. You see this? About the y, it's that solution itself that was provided. So if the left side is equal to the right, then this particular solution or this particular equation is a solution of this differential equation. If you would be asked what type of solution is this? This is a particular solution. Why am I certain that it's a particular solution? Does not have any C. So it's a particular solution. Okay, so we're done with module. So we're done with module 1. Okay, you will get your quiz on Monday, 4:30 to 5. Then I will continue with first order differential equations for the next 30 minutes. Any question, class? I will stop sharing now. If you have any questions related to the materials that you see in Canvas or in the problem set, you may work on that, start working on that because the deadline I think is next week. You can message me in our GC, that way your classmates can also see your question. They may have the same question as you, or they may have the same concern as you. So I can answer the question only one. But if you want to ask it privately, it's okay with me. But I encourage that your questions be posted in the GC. Okay? So any questions, class? Have any questions? I gather that you don't have any questions. We still have 5 minutes.
Miss,
Yes.
ang problem set, Miss, individual, no?
Kung wala siya nakabutang for now na it is a group requirement, then it's really individual.
Sige, Miss. Thank you.
Okay. Some more questions? Even if it's an individual requirement that you will need to submit, you can still collaborate with one another. That way you get to share ideas. It's just that you are to submit it individually. Any questions? So we wait for the merging. There are 4 things that we need to do next week. You need to do your grouping because we have already the final course. I need to give you my final consultation hours. I need to give you your personal Google Drives. And most importantly, I need to give you your final schedule with the asynchronous and of course the synchronous times of meeting. Okay? But if I don't post any announcement in Canvas, we will meet at the same time on Monday, Monday. As to what link you will use, it's in Canvas already because every Monday we have the same link. It's a recurring link that I have set already for all the Mondays. Okay, if there are no more questions,